Hello friends, in this video we're gonna draw the Venn diagram of n-type and p-type semiconductors, energy Venn diagram indicating the position of Fermi level. Okay, so let's start with the n-type, and before we start, please subscribe the channel, also share with your friends, hit the thumbs up button, and don't forget to hit the bell icon so that you get notified when new video will be uploaded. And please support me, inspire me to create new contents for you, and help me to grow my channel. So now let's start with the n-type. So what happens in n-type semiconductors? So in a semiconductor which is pure, that means which is which is an intrinsic semiconductor, we used to add some impurity to get the n-type semiconductor. We used to add pentavalent impurity. So we're gonna add atoms of whose valency is 5. So here, like arsenic. So as you can see in the figure, this is arsenic atom, and red electrons are the electrons of arsenic atom, which are shared with the 4 silicon atoms. And as 4 electrons are shared with 4 silicon atoms, then 1 electron left, which is now free. So which is now free. That's why what happens, addition of arsenic to a certain amount of arsenic to silicons, it gonna it gonna provide millions of free electrons in the semiconductor. So that as a result, that's why what we're gonna have, so in conduction band we're gonna get free electrons. Here you see free electrons, and number of free electrons in conduction band, that's gonna be more than the holes in the valence band. It's something like this. Suppose few electrons are jump from the valence band after after gaining thermal energy. Suppose these are holes, okay, and few electrons jump to the conduction band, and due to the addition of pentavalent impurity, so we're gonna have more electrons in conduction band compared to the holes in the valence band. Okay, this is valence band and this is conduction band, right? And this gap is called forbidden band. This gap is called forbidden band, and this dotted line represents Fermi level. This dotted line represents Fermi level. Okay, so this dotted line here, you can see this line is called Fermi level. So what does Fermi level mean? So let me write here. This is the definition of Fermi level: the highest energy level occupied by electrons at absolute 0 Kelvin temperature. 0 Kelvin temperature is called Fermi level. Okay, so hope you have understood this. Now let's discuss about the p-type semiconductors. Okay, so in p-type semiconductors, what we used to do, we add trivalent impurity like boron. This is boron. Okay, so as it is trivalent, so it gonna have that means I want to say it has 3 electrons in its outermost shell. So it gonna share 3 electrons with 3 silicon atoms. So one in the bone between the boron and silicon, so one hole will be left. Okay, one hole is left because it has only 3 electrons that can that boron can share with 3 silicon atoms, but to share with the 4th silicon, it has no electrons in the valence shell. That's why there will be a hole. Okay, so due to the addition of trivalent certain amount of trivalent impurities, we're gonna have here holes, more number of holes. Here you can see more number of holes in the valence band. Here we're gonna have, and few electrons in the, let me use the red here, in the conduction band, and number of holes is more than the electrons in conduction band. And here we're gonna have holes, number of holes is more than the number of free electrons. So this is Fermi level. Here you see dotted line is the Fermi level here. and the majority charge carrier here, the holes, that means which are positively charged holes, these are majority charge carrier. And this gap is here, you can see this gap is forbidden gap. Okay, forbidden gap, you can say forbidden band, right? And this red one is valence band, and this one is conduction band, right? And in case of n type, here you can see, let me come here. So in this case we have more number of free electrons, so electrons are, that means negatively charged electrons are the majority charge carrier here. So hope you have understood these things. So if you like my video, please share with your friends, subscribe to the channel, okay, inspire me to create new contents for you. So thank you for watching, see you in the next video.